In this video, we're going to look at probability equation questions. So in this example, the question states a box contains n chocolates. 6 of the chocolates are soft-scented. 2 chocolates are chosen at random. The probability that the 2 chocolates are soft-scented is a third. Form an equation involving n and show that it simplifies to n squared minus n minus 90 equals to 0. Then part B says, find how many chocolates were in the box originally. So what we're going to do for a question like this is say, right, so I'm choosing 2 chocolates. 6 of these chocolates are soft-scented. So the probability, so I'm going to write the probability of me choosing a chocolate that is soft-scented, so I'm going to write soft-scented here. Or there's 6 of them that are soft-scented. So 6 out of the total, which is n. So that's on the first time. So the first selection is the probability of me choosing a soft-scented chocolate is 6 out of n. But when it comes to the second selection, I've already chosen one of these soft-scented chocolates in my hand. So the number of items will go down by 1. So instead of 6 soft chocolates now, I've only got 5 soft-scented chocolates. But because I hold that soft-scented chocolate what I had in the first selection in my hand, I don't have n anymore. I've got n minus 1. So it will be 5 out of n minus 1. That's going to be the probability of me choosing a soft-scented chocolate on the first selection is 6 out of n, and the probability of me choosing a soft-scented chocolate on my second selection is also 5 out of n minus 1. So I'm also going to write probability of soft-scented chocolate. So now that we've got the probabilities written down, the key thing here is the word both or and. In our case, we've got 2 chocolates that are soft-scented. That is basically meaning a soft-scented chocolate and a soft-scented chocolate. The key word here in probability, and always means times. So does the word both. So in other words, the probability of me choosing a soft-scented chocolate for the first selection we know is 6 out of n. And, which is times, the probability of me choosing a soft-scented chocolate again for the second time is 5 out of n minus 1. Now they've told us that the probability of both chocolates being soft-scented is a third. So this will be equal to a third. So now we can do 6 times 5, which is 30. n minus 1, I'm going to put a bracket around it. And then on the denominator, we can multiply them. N times n is n squared. N times 1 is n. And this will be equal to a third. Now, what we're going to do here, we're going to use the process of cross multiplication. So we take 3 times by 30. Take all of n squared minus n and multiply it by 1. So 3 times 30 is 90. And that gives me 1 times n squared minus n. So now we want positive 90 to go on the other side. So I'm going to minus 90 on both sides of the equation. So I get n squared minus n minus 90 equals 0. And that's what we had to do for part A. And then part B says, find how many chocolates were in the box originally. So we can do the following. So we can say, let's factorize this. So don't forget that the minus at the end always means different signs. So I'm going to annotate this here and say different signs. So we've got different signs in both brackets. So we've got n minus 10, n plus 9. So n minus 10 equals 0, or n plus 9 equals 0. So we can add 10 on both sides here. N equals 10. Minus 9 on both sides, or n equals minus 9. Of course, n equals minus 9 is invalid. We can't have a negative amount of chocolates, so we can say this is invalid. So the answer is n equals 10. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So in this example, the question states a bag contains n red counters and 5 blue counters. 2 counters are taken randomly from the bag. The probability that both counters selected were red is 1 out of 6. Form an equation involving n and show that it simplifies to n squared minus 3n minus 4 equals 0. And part B states, find how many red counters were in the bag originally. So we do what we did last time. We say, well, we want the first selection to be red. So the first selection being red, what does that mean? Well, I've got, how many counters have I got in total? I've got n red counters, 5 blue counters. So n that are red, so n red counters. And I've got 5 blue counters. So in total, I've got n plus 5 counters. That's the first thing to realize. So the probability of me choosing a red counter on my first selection is I've got n red counters out of a total of n plus 5 counters. Then what happens on my second selection? So on my second selection being red, remember I've taken a red counter, I'm going to hold it in my hand. I am not putting it back into the bag. So I don't have n counters anymore. I've taken one out, so it's going to be n minus 1. And we need to reduce the number of the total by 1. So instead of n plus 5, we reduce it by 1, so we get n plus 4. Very important you write this out properly. So now that we've got that, we know that the key word here, both, means multiply. So we're going to take the first probability, n over n plus 5, multiply that by n minus 1 over n plus 4. Whenever you've got more than one term in algebra and you're multiplying it, it's good to put a bracket around it. So this is now equal to a sixth. So now we can expand the brackets out. N times n is n squared. And then n times minus 1 is minus n. So we're going to multiply 2 brackets out here. So I'm going to do it on the top. N plus 5 times n plus 4. N times n is n squared. N times 4 is 4n. 5 times n is 5n. And 5 times 4 is 20. So that simplifies to give me n squared plus 9n plus 20. So we get n squared plus 9n plus 20. Now this equals to a sixth. So now we can cross multiply, do 6 times all of n squared times n, and do all of the denominator times by 1. So now we can simplify that down. So 6 times n squared is 6n squared. 6 times minus n is minus 6n. And 1 times the denominator simply gives me n squared plus 9n plus 20. Okay, to solve a quadratic like this, we're going to bring all the terms to one side. So we minus n squared here, minus n squared on this side, meaning that the two n squares here cancel out. And we're going to minus 9n on this side and minus 9n on this side. And then these two terms cancel out, and minus 20 on this side, hence minus 20 on this side. And likewise, they cancel out. So what happens? We can simplify this down. 6n squared minus n squared is 5n squared. Then we can have minus 6n minus 9n is minus 15n. And then we've got the minus 20 here. And all of this equals to 0. Now notice that what we're trying to derive is n squared minus 3n minus 4 equals 0. And the way I can do that is to divide everything by 5. So I'm going to divide 5. This symbol means this implies. So we do 5n squared divided by 5 is n squared. Minus 15n divided by 5 is 3n. So we get minus 3n. And minus 20 divided by 5 is minus 4 equals 0. And that should be exactly what they have here. And it is. So we formed the equation. Now we're going to solve to find out how many red counters were in the bag. And don't forget, the question does state that there were n counters that were red. So when we find the value of n, this will give us the result required. So now we can say, okay, so we can factorize this quadratic. The minus at the end means different signs. So we could write different signs here just to remind ourselves how to factorize a quadratic. So we get n in one bracket, n in the other bracket, and 1 is a minus, 1 is a plus. So we want to get minus 3, so we get minus 4 here plus 1 equals 0. And we can say n minus 4 equals 0, or n plus 1 equals 0. Solve the quadratic, plus 4 here, plus 4 here. So n equals 4. Minus 1 this side, minus 1 this side. Or n equals minus 1, but you can't get a negative number of red counters. So we can say this is invalid. So therefore, n equals 4, or there were 4 red counters in total in the bag.